Thank you very much, Lucy. Good afternoon, everyone, or good morning. My name is Chris Clark with the Bioprocess Systems Alliance. As Lucy indicated, thank you all for joining on today's webinar. Lucy, I will keep this very brief so we can get into the material that we're here to discuss. But I just briefly wanted to thank BioPhorum, Lucy, Nick, and the team there for including BPSA in this event. We're happy to partner with you guys. I don't have to tell this audience how important sustainability is and how integral single-use systems are to bioprocessing. So I'm very happy that we are looking at recycling this morning and going to be hearing from one of our members, in particular Sartorius, about this. So thank you again for having us. Next slide, please. For those of you who may not be familiar with BPSA, we are a trade association based in Arlington, Virginia, right outside Washington, D.C. We have about 70 members, and we're focused on advancing single-use technology and bioprocessing. And as I indicated, sustainability is a big part of that. Next slide, please. We wouldn't be able to co-host this program or host a number of other programs without the support of our dedicated sustaining sponsors. So I just wanted to briefly mention them here, including Sartorius that we'll be hearing from today. So thank you to all our sponsors. I see some of you have joined the webinar today. Next slide, please. For any of you that may want to learn a little more about BPSA and what we do, I'd encourage you to consider joining us this July at our Single-Use Summit in Washington, D.C. We have program and registration information on the website. So please feel free to check out the website for more information. And next slide, please. And if you do have any questions or would like to know more about the Alliance, please don't hesitate to contact myself, BPSA Senior Director Jeanette McCool, or Tatiana Lecheva. But with that, again, Lucy, Nick, and the team there, thank you very much for including BPSA. Very excited to have the discussion this morning. Thank you all for joining us. And with that, I believe I am turning the mic over to Nic Coles, former Forum Director at BioPhorum. Thank you.
That's great. Thank you, Chris. And we're delighted to have BPSA with us, a really important partner. So hello, everybody. Really excited that we can kind of pull this audience together to start talking about some of these challenges that we are facing collectively. I just wanted to do a little bit of work at the beginning to frame where this work is positioned, why we think it's important, and some of the things that we're trying to pay attention to in BioPhorum before we hand over then to some of the experts in our field who are leading particular areas. So in terms of the BioPhorum sustainability community, we're now just over 2 years old, and we came together because of a number of reasons, which I am sure you are all familiar with. So we know that the climate crisis is now widely accepted as the biggest threat to global health. The biopharmaceutical industry exists to advance human health, and we now know that the pharma industry is contributing to healthcare emissions, which contribute to that climate crisis. And the industry is growing. So it's really important to all of our members and to our member companies that we decouple our impact as a sector from growth across all environmental measures. So at BioPhorum, our members are working to translate some of those corporate commitments, which I'm sure we're all familiar with, into tangible operational action that can be taken either at the bench or at the site level. So working with each of our technical communities across the product lifecycle to embed environmental excellence. And that's focusing on emissions, it's focusing on material use, and it's focusing on water, because obviously biopharma water is an important material for biopharmaceuticals. So we're thrilled to be able to host this webinar alongside BPSA, because BPSA represents suppliers who are critical to the manufacture of biopharmaceuticals, and with whom we really need to partner to develop those radical solutions to meet the challenges we face. Next slide, please, Lucy. So with so many standards and frameworks and initiatives, BioPhorum members came together in 2022, and one of the first things that we wanted to do as a community was to develop a roadmap for the industry, because there wasn't one at that time. So you can use the QR code at the top right there to download it. So really what this roadmap did was recognise that organisations are at very different stages of maturity, and that we don't have a shared language across the industry for environmental sustainability. So we have different definitions, for example, regarding emissions goals. I think that's changing. So there is there's a coalescence around the science-based target initiative definitions. But in other areas, in terms of nature or water or plastics and material use, we have lack of standard definitions, lack of standard data sets. So it's really difficult to compare our performance and look at where the big opportunities are. So that means there's a lack of good data to drive decision making and direct improvement effort. So the first thing we did was to agree a vision, which is stated there, to improve patient health by providing biopharmaceuticals while respecting the planet and responsibly using its resources. So nothing that you wouldn't expect to see there in a good vision. We identified 3 goals, and we've since updated those goals to include a 4th, and that's in view of the growing focus across all industries in terms of the impact on nature and industry's responsibility in terms of that impact on nature. So we'll be doing some work on that area towards the end of the year. We looked across the entire value chain and the whole product life cycle. So we looked from raw materials through to product use and end of life. And we're now building a maturity model to identify measurable benefits to track the industry's performance. So our work is helping to identify areas where collaboration will accelerate the industry and individual organisations' progress in relation to environmental impact. So there's an awful lot that we can just get on with and do ourselves as individual companies, definitely. But there are areas where we do need to collaborate, or we won't build our way out of this. And embedding circularity is one such topic. So anybody who's working in this area will know it requires a fundamental mindset shift. It requires new business models between suppliers and license holders, and it requires a completely new infrastructure. So I would suggest that it's near impossible to have a circular product in a linear economy. And that's why a cross-value chain approach to responsible use of plastics in the industry is so important, to both the way that we manufacture biopharmaceuticals and the way in which we deliver biopharmaceuticals. So today we're going to focus on some of the solutions available for the manufacturing domain, and then in other parts of our work we're focused on the delivery end. So next slide, please, Lucy. So I'm sure that everybody on the call is much more of an expert than I, but just wanted to sort of level set so that we all had like a really clear understanding of what we mean by circularity and why circularity is such an important strategy. And that will help us position where we are hearing some of the examples later on in the call in terms of that waste management hierarchy. So in terms of this, I guess, is not news either, but our kind of linear take, make, waste economy and the pursuit of infinite growth has led us to a position where globally we have breached many planetary boundaries. And the effects of these are starting to show up in many places, but most obviously in terms of climate change and biodiversity loss. And if we focus our improvement on, say, emissions alone and look at efficiency alone, it's only going to get us so far. We really need to tackle consumption. So moving to a circular model where we reduce consumption of virgin material and we develop products in such a way that we maximize their value during the product's use and the end of life phase is really important. So next slide, please, Lucy. So just to kind of give us a position, and this is not to worry anybody. So plastic production is accelerating, and it has accelerated since the Industrial Revolution. And though the amount of plastic used in the healthcare and the pharmaceutical sector is a relatively small portion of all plastics produced, I mean, it is, Magali probably has some stats, it is a relatively small portion. There is growing societal pressure and an expectation to shift to responsible use of plastics. So that means looking at the source of plastics, be that virgin or recycled, be that bio-based or fossil-based, and it means looking at the end-of-life treatment of plastics, including landfill, incineration, recycling, and aiming to reduce as much mismanaged plastic as possible. Next slide, please. So the call to action on emissions is really clear. It's definitely getting clearer. There's lots of regulation. There's lots of standards frameworks. Your organisations, I'm sure, will all have strong emission reduction targets. And you'll be familiar with some of the asks that are starting to percolate through the healthcare system. So I've shown here the NHS as an example. The call to action for circularity is getting louder. So for many years, license holders and suppliers have made internal commitments regarding waste management, and good progress has been made. It definitely has. But what we're now seeing is a number of initiatives signposting a broader focus on circularity and specifically plastics use, including the World Business Council for Sustainable Development Circularity Protocol, the Plastics Treaty, the EU Packaging Directive, a raft of initiatives. So in support of this direction, we now see other actors in the system. So we have the Sustainable Markets Initiative Health System Task Force specifically call out responsible use of materials in their recent letter to suppliers. And I would add that suppliers in this context are suppliers of the healthcare system. So that includes license holders, it includes contract manufacturers, and it includes consumable and ingredient suppliers as part of that health system value chain. So the work to address the end-of-life treatment of single-use technology is a really important part of our industry's response to this call to action. And it's not easy. The infrastructure is not well developed. Our plastic is contaminated. It's multi-layer with a mixture of polymers. If we are going to solve this industry challenge in time, we really need to work together to share what works, to create stronger demand signals for the infrastructure we need, and to engage with regulators to smooth the path. So I'm delighted to share this webinar with leaders from across the value chain working towards responsible use of materials. This is the first time we've created an open forum for discussion in this way, and I really hope that there will be many more leaders who come forward to share the work that they're doing over the coming months. So thank you very much for your time, and I hope you enjoy the rest of the session. I'm going to hand over to Katharina of Roche now to give you a license holder perspective.
Thank you, Nic. I hope you can all hear me well. And I also want to thank the organizers for giving me the opportunity to present the perspective of the pharmaceutical industry on this important topic. I'm Katharina Bruno-Thakur, and I'm working at Hoffmann-La Roche in pharmaceutical development in Basel, in Switzerland, as a project leader, as well as a sustainability lead for the pharma technical development unit in Europe, which focuses on the development of parenteral therapies. And in this capacity, I'm also a member of the BioPhorum Sustainable Plastics Workstream. So why is this topic so relevant for us in the pharmaceutical industry? We already heard it. Single-use technology, plastic is actually critical to develop and manufacture in innovative therapies. And that's because in many cases, single-use technology is actually more sustainable than the classical stainless steel process for many reasons, such as the gray energy of steel, the operational footprint during cleaning, sterilization, the HVAC, and many more. So as a result, we often end up with significant amounts of high-value plastic materials, which could, in theory, be recycled, but at the moment, it's really difficult, and they have practically a low recyclability potential. This we need to solve. So as a result of that, we are forced to either incinerate or landfill these materials as of now, and that leads, of course, to greenhouse gas emissions. It could create microplastic it depletes natural resources, and obviously there's simply a very negative perception in the public regarding plastics. So the BioPhorum workstream here is a group of suppliers and license holders, as you have heard, combining forces to standardize a way to capture the organizational and regional volumes of plastic in order to increase the clarity regarding the potential for the footprint reduction, and thereby also increase the reuse and the post-use recycling of this material. And this model of circularity should help us to also support the UN Sustainable Development Goal, in this case number 12, to ensure sustainable consumption and production patterns. While we as license holders maintain to provide therapeutic solutions, which is a key element of the Sustainable Development Goal number 3, to ensure healthy lives and promote well-being for all at all ages. So next slide, Lucy, please. So the activities of the BioPhorum workstream here is on one hand to quantify plastic waste in our industry in terms of mass and material of construction, to enable creating baselines and to enable benchmarking, and furthermore enable also then solution-focused discussions with the recycling companies and solution providers. We also work on trying to elaborate on the current best practices for waste management of the different players and stakeholders here, also in collaboration with academic research, in this case with KTH from Sweden. And this work should also help us to identify waste diversion opportunities. All of that will result in educational resources such as this webinar here, publications, papers, and similar. So next slide, please, Lucy. I want to just go into a bit more detail about the quantification methodology. What we're doing is to model essentially a typical biosynthesis process, drug substance, a 2,000 liter scale bioreactor with a average titer and a traditional buffer prep methodology. Additional assumptions and input parameters are coming from BioPhorum members' publications, for instance, or also from survey responses, which are anonymized and aggregated to maintain confidentiality. That way we can really get a good picture of the amounts of bioreactor bags, ancillary items, tubings, filters, etc. of this process. And this piece of work is intended to be finalized fairly soon, within this quarter of 2024. And then we can also, of course, repeat this exercise for different scales, different processes. On the next slide, you see the second piece of work or activity we're having. So we are essentially discussing potential solutions for challenges such as trade-offs, performance versus recyclability of these consumables, because as license holders, we cannot really compromise on the performance or quality of our products, because if we have to write off a batch, this is obviously not in the interest of the sustainability. We have to be sure that the process works, it's qualified, it's validated, and it's very difficult to change, or at least time consuming, and a lot of resources are required to change anything. So we have to be sure that it works, irrespective of recyclability or not. There's a lot of controversy on the terminology of recycling, downcycling, circularity, open loop, closed loop, so we're trying to get a bit of understanding here as well. We also identified limited resources on waste handling capacity. There's a lot of competition actually, and that would warrant investments for scale up, of course, but also investors and companies would need to know the trends of the volumes in the future. There's also a multitude of regulations that we're dealing with in the different geographies. For instance, regarding contamination, for instance, regarding cross-border trafficking of post-use material, and more, much more. And yeah, I've touched upon the terminology discrepancies, which can lead to different interpretations or some misunderstandings. On the next slide, you will see that this waste management hierarchy is essentially trying to create this alignment across industry and stakeholders across the value chain with respect to what is really the best recyclability solution, depending on the polymer type and also the implications on the environmental impact, on the design, on the performance of the different consumables. So with this, I would like to switch gears a bit and put all of this work into the perspective of us as Roche, as a license holder. On the next slide, thank you. You will see our mission and environmental goals. Our mission obviously remains to deliver innovative therapies to improve patient outcomes, while we're also reducing the total environmental impact by half until 2029, in order to ultimately be carbon neutral by 2050. We are also committed to the Science-Based Target Initiative. And on the right bottom, you see the last couple of years metric for our environmental performance, which you can see is improving over time, but there's still some time to go. The red dotted line is now the target for 2025. So we're confident that we will reach our short, mid, and long-term targets, but we have to stay diligent and we have to improve and have to find solutions for the current problems. And on the next slide, you see a little bit more on plastic-specific recycling or waste management metrics. Some of the metrics we already reached our 2025 goals. For others, we're still on the way. This is about reducing the waste in general, increasing the recycling rate, and reducing plastic consumption as such. So in order to really improve there and make sure we hit our targets, we have made an exercise on the next slide. You can see the outcome already, whereby we investigated a typical drug substance manufacturing process that is based on single-use technology. In this case, we have analyzed 61 consumables that are potentially recyclable and that are also available for us to analyze, and categorized them regarding the material of construction and the weight. This particular case, due to the nature of the molecule, is a kind of a worst case, I would say, because it needs a lot of material input. Standard platform antibody would probably use only half of that. But more importantly than the total absolute numbers of plastic waste for this, we have now the composition, more or less, of this plastic waste. And as you can see here, this is kilograms in the scale. We already have almost 200 kilograms of just packaging material, which could be recycled mechanically, simply because it's not contaminated at all. On the other end of the scale, we have filters that are probably the most difficult to recycle pieces of the single-use assemblies, because they're contaminated, they are very rigid, they're hard to take apart. They often contain also problematic substances like halogenated carbohydrates and PFAS and such, which can interfere with any recycling process. We also have small amounts of metal parts, which of course have to do with the stirrers in the stirrer bags or in the fermenter. Some of them are welded in, some of them are attached magnetically. So in either way, we have to get them out of the mix, because they can compromise the shredders and they can compromise the recycling process. We have a large amount of silicone, which could be recycled in theory separately, but there's very few companies who actually offer this type of recycling technology. Another solution would be to essentially replace them with other plastics, which then would allow us to put the silicone in this big mixed materials section, which could, for instance, be a source for chemical recycling pyrolysis processes. Provided all of these, except the packaging materials, can be decontaminated, because they're obviously contaminated with chemicals, with genetically modified organisms. So there is this is heavily regulated in Europe and also in other parts of the world. So this needs to be solved before we can direct this material to any kind of recycling solution. And so this data essentially provides us with already a very good basis on starting to find solutions to make this a circular process. And this will help us ultimately to reach our internal sustainability goals and to ultimately be also part of a global sustainable circular economy. And with this, I'm already through with my slides, and I hope I could make it a bit more transparent, the challenges that we as end user of this value chain face. And I'm handing back to Lucy for some additional information.
Thank you. Good morning, everyone. First of all, thank you to BioPhorum and BPSA for inviting us to be here. We're going to talk about some of our specific experiences here with Fujifilm Diosynth Biotechnologies in Texas and some of the successes that we have found with sustainable management of our single-use plastics. Mike Wurst, CEO and President of WTS, and David Raby, Senior Environmental Services Manager, will also be contributing to the conversation. Next slide, please. So single-use technologies, and anywhere from labware to biopharmaceutical manufacturing materials, represent a sustainability problem for our industry. I don't think there's any necessarily really accurate total out there, but there's one estimate floating around that it's about 5.5 million tons of single-use technology waste generated by the biopharmaceutical industry globally each year. And life cycle analyses tend to be presented by manufacturers of the single-use materials, so it doesn't necessarily represent the challenges that the generator is going to face in terms of waste management, cost, any corporate ESG goals, et cetera. Next slide, please. Dave, I think this is where you jump in.
Yeah, thank you again. So this is just a quick little snapshot on our 3.5-year journey here with Fuji. Our initial goals were to minimize landfill footprint and increase sustainability. First solution, the initial solution that we encountered was the autoclave to landfill. Standard in the US. We have lots of open space, lots of landfills that are readily available, generally a least expensive option, very uncommon around the rest of the globe. From there, we knew we had to get out of the landfill. That was our primary goal. We started exploring other options. One of them was manufactured-based recycling programs, Kimberly-Clark, VWR. We found they were limited in scope. They did not fit our need with the volumes that we were generating, specific to one type of plastic or one type of vendor's material. So not good by our needs. Maybe on a small scale setting, but not for us. We went into a no sort recycling. Easy for us here because we could collect everything together: cardboard, paper, plastics, metal, wood. Sorted off-site. The downfall with that we found was there's cross-contamination with all that material. 50 to 60% of that is actually being recycled, and due to the contamination, the other stuff was actually winding up going to landfill, which is, again, where we wanted to avoid. Next slide, please. We went to and explored waste to energy. Very promising, but it was burning plastics, again, generating steam. The steam is used to create electricity. However, downfall with that, no recycling, and the ash coming out of the waste to energy facility is ultimately going to landfill. We are currently at a eco-sterile process, which involves a microwave technology and heat to do the sterilization for the plastics. It is shredded. Unfortunately, we have mixed grade plastics all commingled, which cannot be recycled. So there is sorting that needs to be done. But once that sorting is done, we have single grade plastics now that can be introduced back into the plastics world for 100% recycling. And it can be used to produce things other than park benches and, decking. We can put it back into the plastics bottle marketplace and bags and commerce. So very good. Next slide, please. So this one, I'm not going to dwell a whole lot on this, but in moving away from the waste energy or the autoclave into the eco-sterile technology, there were some definite other great sustainability goals that we could share or contributions. So we've estimated our water savings alone by just switching from the autoclave to the EcoSterile is about 200,000 gallons of water we've eliminated or not had to use because of that technology shift. Landfill avoidance, 1,850 cubic yards, which is about 675,000 bricks that we've eliminated from the landfill. Next slide, please. And real quick, I just want to touch on our successes. Last year for Fujifilm, we generated over 1,000 tons of solid waste. We were able to divert 683 tons, so 68% of our solid waste we've diverted from the landfill. 326 tons of that was the single-use plastics. Really, this is just to illustrate, we are on a marathon here. We are on a marathon race. Every step that we can get closer to the finish line is where we need to be as an industry as a whole. So with that, I'm going to hand it back to Erin and let her discuss some of the limitations that we found.
Erin, we just need you to come off mute.
Sorry. Okay. Start over. Okay, so some of the limitations we've experienced. Once we hand these wastes off to the third party, we can't account for 100% of it, but we feel confident that 60% of the no sort waste is definitely diverted from landfill. The additional 40%, we're not entirely sure. On the EcoSterile, we're confident that it's about 80% of the single-use technologies are diverted from the landfill. And the other 20% is just material that's simply beyond a state that can be recovered, or just is material that has no value in a recycling industry. Now in our case, we have a regulatory opening to where we can actually put single use that comes from viral manufacturing into ultimately into a recycling waste stream. Some state environmental programs still don't allow that. So there's a hurdle. There could be a potential hurdle there for some manufacturers. As far as we try to minimize how much we need to rely on individuals at the point of generation to have to segregate materials, but there is to some extent that's a necessity so that we don't end up with wrong materials going into the wrong waste streams. For example, we do occasionally have to pull containers of chemicals out of our bins that collect the single-use waste. Next slide, please. Availability of service providers and recyclers. I mean, that's still fairly limited. The recycling industry isn't necessarily keeping up with our industry and the needs of our industries. Dave mentioned that we tried some of the manufacturer-sponsored recycling programs, but those are typically limited to that vendor's brand and or to just single plastic types. So they're not really good for large-scale single-use technologies that have combined multiple materials. Geographical reach. Again, locations of service providers and recyclers is definitely going to impact cost. It's going to, depending on what your sustainability goals are. Transportation, that's a cost, but that's also representing some additional emissions. So how far you have to transport the material could go backwards on what your zero emission goals are. Cost of freight, shipping to service providers. Again, transportation costs are frequently higher than the cost of treating and handling the material itself. The other kind of big limiting factor is that recycling does not necessarily represent cost savings or rebate or even cost neutrality to the generator. Frequently, managing waste into recycling waste streams can actually cost more. So that can result in a little bit of sticker shock. Next slide, please. Also, as Dave sort of alluded to already, the single-use technologies, these are mixtures of multiple grades of plastics with varying degrees of value or potentially no value. And then they do include some metals, clamps, magnets, and so forth that can be potentially harmful to a treatment process. In our case, with the eco-sterile system, small pieces or small units of metal are okay. But we have to be careful because it is possible that, a large chunk of metal could damage their equipment. And then I'm just going to allude to the fact that the different types of plastics we're talking about are thermosets, which are hard, rigid plastics that have no value for recycling. And then the thermoplastics, which are the soft, pliable plastics that can be remelted and reformed. And then Dave's going to retake the conversation and talk a little bit more about the plastics and how we manage those.
We will not spend a whole lot of time on this slide. It's merely to demonstrate this is not an easy task. Most of our single-use plastics and consumables, if they were one type or grade of plastic, makes our life a lot easier. Unfortunately, they are mixed. We have Nalgene tubes mixed with HDPE bags, mixed with the magnets and the metal clamps that Erin has talked about. So all of this takes time and effort, and it results in an expense to sort through all of that to get it into the recycling world, which is really where we want to go for the circularity sake and benefits of everyone here in the globe. So with that, I'm going to hand it off to Mike, and he's going to wrap up our presentation. So Mike, it's all you.
Thank you, Erin. Thank you, David. Good day, everyone. As we noted, we're on the journey, a 3.5-year journey, and we're not beat back by the limitations or the hurdles we have. And so here's some of the steps that we see next for us as we continue this journey. For us, it's really important at the point, as close to the point of generation, to be able to sort and segregate materials. And that requires engagement with all of our teammates at our sites, education, training, and then making sure that they have access to the proper containers to collect the materials into. We cannot recycle, we cannot return materials back to their original form if we don't collect them. And so it's an important step, one that we find folks become very excited about when we explain the reasons and the benefits for making that happen. There's also challenges on site, especially with clean rooms and other areas of the materials and of the operations. We're working to optimize outbound shipments. We then move, as we discussed, this eco-sterile process to sanitize materials, but we only want to sanitize what needs to be sanitized. And that's why we're moving materials, segregating and sorting materials more into the proper end directions. Next slide, please, Lucy. And we're back to separation and sorting. After sanitizing materials, there's still a variety, as was noted previously in some of the materials composition studies that have been done. And so after materials have been sized and gone through that sterilization process, there's still the opportunity to pull fibers out and pull out some of the value that we're looking for, so that we can move the right materials into the advanced recycling and really get to the value and minimize the use of virgin materials. And so we're seeking to, for every ton of plastic waste we process, society reduces the need to process 1 ton of fossil-derived feedstocks. Next slide, please. We think about this as concurrent solutions. 68% of the materials are out of landfill to date. There's no on-off switch here with the responsible management of plastic materials and waste materials. And so it takes a journey. There's concurrent solutions that hopefully help to reduce some costs so that you can reinvest in other areas to get at the value. One of the options available in the States is the beneficial reuse, and perhaps globally, such as alternative engineered fuels. This process takes industrial materials, plastic materials, cardboard, paper, and creates a fuel product that is an alternative to fossil fuels, carbon and also natural gas. The use of that then is in kilns as a fuel source, and kilns typically run much cleaner than other waste to energy sites. Any ash that results from that process is then used in the cement product down the road. Next slide, please. And as the case is today, this is such a powerful moment for all of us, I think, to be collaborating together here, and the work of BioPhorum and BSRA engaging together. Sustainability, the success means we may have to collaborate with competitors as well. And so we're engaging across the industry, across the value chain. And then, as we mentioned earlier, looking at on-site shredding, moving some equipment on-site to size materials so that you can optimize shipments. And overall, take an approach that we need a combination of multiple strategies together to have the success. And thinking about what we're spending today on waste disposal or waste management of these materials, thinking about that as an investment into closing the loop and moving towards that. What we're spending today, as I mentioned, it's not an on-off switch. It's not going to be suddenly we have value for this material, but we need to invest into operations, maybe invest into some capital equipment, invest into some other technologies as we move along the journey. And so I turn this back to you, Lucy. Thanks for the opportunity.
Hello, good morning, good afternoon, good evening. I am Magali Barbaroux. I'm part of the Sartorius Corporate Research Department, where I'm leading some of the environmental sustainability programs with a strong emphasis on plastic circularity. I'm also chairing the BPSA Sustainability Committee, and I'm also contributing to the BioPhorum Sustainability Stream. And I am very happy to attend this webinar co-hosted by these two industry groups and to co-present with Bernd, since, as we all know, sustainability is a team exercise. So Bernd, if you want to introduce yourself.
Yeah, also hello from my side. Bernd Garska is my name. I'm within Covestro, and I'm responsible for the technical marketing in the healthcare life science field for polycarbonates, and I'm also quite happy to have the opportunity together with Magali present our joint work on the concept for a small-scale polycarbonate-based bioreactor recycling in a closed loop.
Next slide, please. You see. So here it's just a standard disclaimer for the slides. So we won't comment anything here. So you see if you can go to the next one. Okay, so why are we co-presenting? So Sartorius is a supplier of the biotech industry and life science research, and we are using plastic, and we are not using plastic to use plastic. We are using plastic because this is sometimes the best material to fulfill the purpose of our activities. And we have some contact with Covestro, and I will let you introduce Covestro.
Yeah, thanks. For those of you who are not aware who Covestro is, we are one of the leading companies in the world of plastics. And for today, as Magali has mentioned, we are focusing on polycarbonates. And here it's quite important, and we will also refer to that a bit later. As a raw material supplier, it's quite a big advantage that we not only collaborate in the field of life science or bioscience, but we are also active within polycarbonates in the field of automotive and electronicals, so in all the other relevant industries that are using polycarbonates. And yeah, as Magali has indicated, we are also highly interested in sustainable solutions and closing the loop for our customers and ourselves. I think that's.
Yeah. Okay, so why this project? I won't go into the details on why we are using we are implementing single-use technology in bioprocessing. As I mentioned, we use plastic because it is often the best material for what we want to achieve and how to support the development of new therapies in a more flexible systems. However, now what we see is that the perception of plastic is really a topic, especially for the young generation. And if we want to continue to use responsibly plastic, I mean, if we want to continue to use plastic, we have to use it responsibly. And what we wanted to do here together with Covestro is really to think about reviewing mechanical recycling, which is on top of the recycling hierarchy today, because it is perceived as a downcycling. And often you may hear as an objection in the field that our products cannot be recycled because they have been contaminated, whatever it means today. And also that we cannot, in our application, include recycled content because the quality of recycled plastic is not good enough. And what we really wanted to do here was to challenge these two positions statements. Next slide, please. Okay, so the project was really to demonstrate on one of our products, which is made of polycarbonate, and you see here a small scale bioreactor made of polycarbonate, mainly more than 80% of the weight. And what we have covered in this study was the logistic, how to collect, sort, autoclave this small bioreactor, but also all the recycling process from disconnection, sorting, granulation. And then we put it back into the same application, same small container, and then we perform some application tests, and this is what we will share with you now.
Yeah, that's my slide. What have we done as Covestro when we have received the bioreactors from Sartorius? So we have reached out to the network of recyclers that we are working with anyhow. And firstly, we have disassembled the bioreactors to check how easy it is to sort PC-based material from non-PC-based material. This was rather easy in this application, so we are really confident that on a bigger scale, this is also possible to do this. Then the material has been shredded, and on the right-hand side, you see that it has been regranulated. The final regranulated material has been sent back to Covestro, where we have assessed the material in our labs to go in a deep quality check of the material, so that we have finally sent it back to Sartorius to execute the next tests.
Yeah.
So next slide, please.
Okay, so we started with the cell compatibility test, which is a test we have developed when we developed one of our film to show the compatibility between plastic and cells. What you can see here, I would say on the picture on the bottom right, is that you see the two families of vessels. The yellowish one are the vessels which have been manufactured using a recycled resin. So it's a little bit yellow, but it's transparent, and this didn't affect at all the cell compatibility. I won't go into the details of the slide. What you have to see is that there is no difference between the virgin and the recycled vessel. So next slide, please. And here it's a cell culture test results. So with two different batch of CHO cells. So these are the Sartorius DG44 cells. And again, what you have to see here is that there is no difference between the black, which is the virgin vessel, and the virgin vessel, yes, and the yellow, which is a recycled vessel. Next slide, please. Okay, so what did we want really to prove with this study? Today, it's always the chicken and egg story. Do we have to design for recyclability if at the end we don't have the infrastructure recycled. So, I mean, what we decided to look at was first on the design, and just to say, okay, if our materials can technically be recycled, maybe if we can be convinced enough, if we work with all the industry, we will have the opportunity to make it happen at scale. So for us, it is really the very first option to check. So we haven't showed some mechanical tests we've done as well, of course, which are the standard tests. So what we have proven is that the recycling process didn't impact at all our manufacturing process. So we process it exactly in the same with the same parameters on the same equipment. As well, it didn't impact the cell compatibility, and we didn't impact the cell culture as well. We perform all these tests with 100% recycled content. As you can imagine, is a worst case, because 100% will mean that we will have a return rate of at least 100%. And because we will have a grow, anyhow, we will have to include some virgin polymer as well in this process. But at least it gives you a good idea of the safety margin we have if we want to include some recycled content, just to answer to this objection about the quality, that the mechanically recycled polymer has not a quality good enough for our application. So what we have proven is that it's theoretically possible. So we have this first milestone of, yes, it could be done in a closed loop. But as well, we have some opportunities in an open loop. And I will let Bernd describe what could be possible.
Yeah, thanks, Magali. And before going a bit into the details, just to clarify some wordings, if we are talking about closed loop today, we are talking about having one application and going back into the same application. That's what we have done in this case study, which as Magali nicely illustrated. Beside the closed loop, the so-called closed loop, there is also the so-called open loop solution, meaning we have material coming from one application, which is then going into another application and help addressing sustainable targets over there. And yeah, let's have a look what besides closed loop applications can be done with material like described in this case study, can also be done in an open loop application. And here it's quite important, coming back to what we have said a few slides before. So one of the strengths of Covestro in this case study was also that we are active in the automotive and the electrical industry. And here those industries are desperately looking for end-of-life material. Yeah, once we have received the regranulated materials, before sending it back to Sartorius, we have tested it in our laboratories. And we have also used the opportunity to use the material to mimic some bi-blend materials that are frequently used in, for example, automotive application or electrical application. And here our laboratory colleagues were able to use the material from this case study to incorporate up to 50% into a standard bi-blend recipe, which was then a bi-blend so-called R50, indicating 50% recycled content, without suffering any quality loss. And here, looking at, for example, in the automotive industry, there is an end-of-life vehicle directive active in Europe. So automotive industry is desperately looking for end-of-life material, and also the electrical industry with fast cycle of their devices and easy or low regulatory hurdles are always desperately looking for material, high quality material from a second or for a second lifetime.
Next slide, please, Lucy.
So yes.
Okay, so as I mentioned, it's a milestone, but it is the first one. And here we will have the same, I would say, barriers or concerns that have been already identified. How to make it happen at scale, how to find a market. As it was mentioned previously, if we want to keep the quality, if we want to maintain the quality, and if we want to limit the impact on the environment, we have to go with mechanical recycling. Yes, of course, we could have chemical recycling in the future. It's still at the pilot scale. So we could take all the opportunities we have for mechanical recycling right now, but it will have to come with identifying the streams, the waste streams, go with a quantity which is interesting enough for a waste collector to find a market for the recycled content, and to look at the overall cost approach, and of course the overall environmental approach, knowing that when it comes to life cycle assessment, if you are in an open loop, it's super difficult to get the credit for the carbon footprint. So we have to think about carbon footprint or emission reduction, but we have to think about decarbonization, but also defossilization or deplastification, or, I mean, we have to look at waste reduction and emission reduction as two parallel things. Hopefully we can at least be carbon neutral, but we have to think that circularity waste reduction is also a target, and especially going away from landfill. As soon as you will compare a LCA where you will compare landfill to waste to energy, it will be a loss, because waste to energy will emit some emissions. So which means we really have to think about what it is that we want to achieve. Next slide, please. So this is one of the slides I present very often. What you see on the y-axis, on the x-axis is a value. So you see from the feedstock to the use of our product in the facility that end users and license holder. And when you see on the y-axis, the input of energy you have to put to make it happen from the feedstock to the use. And then you have what we call the end of life, where you are disposing your product, you do not put it back in the loop. Either you have energy recovery or incineration, or worse for us, landfill. And then you have all the options to return back. What we have discussed today together with Bernd is only a piece of it. We only mentioned the mechanical recycling option in this presentation. Of course, we are working with the industry with all the different options, advanced recycling with chemical solvent or depolymerization or even pyrolysis or back to feedstock. And we also have to look at the biomass option. This is out of scope for today, but it's just a teaser, because maybe this could be the theme of another webinar if it was interesting enough for you and if you learned some things. And this being said, next slide, please. We of course want to acknowledge our teams, respective teams, because I mean, we are two today, but we were much more working on this project. And thank you.
Thanks for your attention.
Thank you both so much for that fascinating insight into a particular option, and an invitation from Magali there to consider whether or not there are other things that you would like to do this same shared approach to webinars too. So please do bear that in mind, because there's a question about that coming later.